So consider this problem statement. So we need to compute the number of real roots for this equation, that is x times absolute value of x minus 5 times absolute value of x plus 2 plus 6, that is equal to 0. So now since absolute value function is there, we need to take the critical points, and based on the points where the definition changes, so based on that we need to solve it by cases, right? So proceeding with the solution, so first of all we'll consider here the case 1. The case 1 here, the case 1 says that x, so if I consider about this, so this, the definition of this absolute value of x will only change about if you go to positive number, means about 0 you can change the points, right? So instead of considering this, I'll consider the other point, right? So for case 1, that is when x is, so for this x plus 2 I'll consider, okay? So when x is less than negative 2, when x is less than negative 2, so for this one we need to check, right? So when x is less than negative 2, so definitely this will expand as 5x plus 10, and definitely this absolute value of x can be written as negative x. So this will effectively become negative x square. So when this is the case, when this is the case, so let me just above this, let me write the equation here. Yes. Now with this case, if I proceed, right, this will be x times negative x, or I'll write it directly here, x square, that will be negative x square, and this one will be negative, so this will be plus 5x plus 10 plus 6, that is equal to 0. Now, so this is my case 1, right? Now on resolving this one, this will be x square minus 5x minus 16, that is equal to 0. So if I apply the direct formula to get the quadratic roots, so this will be 5 plus minus square root of 89 over 2. Now here we can finally write that x will only accept the value with the positive value. It will accept the value only with positive, so this negative has to be rejected. So what is the reason behind this? So reason is, so the reason is simple here, that x less than minus 2, this case we have already considered, that x has to be less than, so here it is given that uh, x less than minus 2, this positive cannot satisfy, right? So effectively I have to reject this positive one, so I have to consider the negative one, right? So why this value got accepted here? Because x has to be less than negative 2. This is the reason actually, because we have considered the case, right? So hence a 5 plus square root of 89 got rejected. Okay, sorry for the mistake. Now in the next one, now we'll go over the next case. The equation remains the same pretty much, and the next case is that this time we'll check from the region that is negative 2 to 0. So here negative 2, negative 2, this x has to be greater than or equal to negative 2, and at the same time less than 0, right? This 0 part I will handle in the next case. Now this one will expand as, so this mode of this absolute value of x will be written as minus x. So effectively this is minus x square, and this one will be minus 5x minus 10 plus 6, that is equal to 0. Now solve this quadratic. So this will be, on resolving this one, will get x as, so x square plus 5x and 6 and minus 19. So this will be negative 1 and then negative 4. These are the acceptable values. Now here out of this one has to be rejected, that is x will be negative 1, right? And reason is very clear. Reason is very clear that x has to be within the range of minus 2 to 0. So this negative 4 is something which is out of boundary. So that's the reason that the other root got rejected. Correct. Now let us go for the case 3. This is case 2 definitely. Now let us go for case 3. Yes. Now case 3 will be that situation when x is greater than or equal to 0. When x is greater than or equal to 0. So now let us go ahead with this one. So this one will expand as x square minus 5x minus 10 plus 6 is equal to 0. Implication sign, of course. And this further implies, so if I apply the quadratic formula, so x belonging to these two numbers, one is 5 plus square root of 41 over, so this is positive and negative both actually, so this is positive and negative both over 2. Definitely one has to be rejected here. So here 5 minus square root of 41 by over 2, that has to be rejected. So the acceptable value for x will be with the positive one, because x is definitely greater than or equal to 0. So negative does not have a role over here, right? So this is the acceptable value, and reason is very clear because we have considered the case itself. I should not write this reason actually, because we have already considered the case. So whenever you have to check the reason, check the case of critical point which we are considering, right? So since this negative factor, this 5 minus square root of 41 over 2 will not satisfy this 0 less or x greater than or equal to 0, hence the other one has to be rejected. Now, so what are the acceptable values that we got? So one of the acceptable root from here, so this is count of 1, and then one from here 2, and then one from here 3. So there are 3 real roots which satisfies this one. So therefore the answer for this problem statement is 3, and hence we have solved it. So here whenever we have absolute value functions associated with the equations, we need to consider the critical points, we need to break those cases, and based on those cases we need to resolve such kind of equations.